right, so reading the question, we have two particles that move along the x-axis, and the position of the particle at time t is given by, so this, whoops, sorry about that. This is the position of particle P, while the velocity of particle Q, which is the other particle, is given by that. So we have a position equation for P, and we have a velocity equation for Q, the two different particles. All right, then the next thing that they give you is particle Q is at position x equals 5 at time 0. All right, now part A says, when is particle P moving to the left? What does moving to the left mean? So remember, moving to the left means that the velocity will equal a negative number. So if you look at part A, we're going to take that velocity. Well, we need to find the velocity of P. We have x of P, right, which is the position. So I'm going to take the derivative. Okay, so what's the derivative of ln? Remember, du over u. So the du would be 2t minus 2 over u, which would be t squared minus 2t plus 10. Okay, now it says it wants to know when the particle is moving to the left. So we know that we're looking for we're trying to find out where the velocity is negative. So I'd like to do a sign chart. And remember, when I'm going to do a sign chart, though, I need to find out where the velocity is equal to 0 or where it's undefined. So the two things I want to look at then is I want to see where it would be equal to 0. So if this fraction is going to be equal to 0, that means the numerator is 0. So that's why I'm setting this equal to 0. And if I want to figure out where this fraction is undefined, I'm going to set the denominator equal to 0. So over here, then I'm going to write t squared minus 2t plus 10 equals 0. Okay, well over here on the left, this is pretty easy to do. We're going to get 2t equals 2, and then so we will end up with t equals 1. Now over here on the right, there is nothing that adds to negative 2 and multiplies to 10. So this is not factorable. The other thing also is if you did the quadratic formula, do you remember when you did quadratic formula, the part underneath the square root was b squared minus 4ac? And just to show you this. So my b squared would be negative 2 squared, which would be 4 minus 4 times a is 1 and c is 10. Okay, now that's what's under the square root. Look at that. If you work that out, do you see that that's a negative number underneath the square root? Isn't that imaginary? So what I'm trying to get at here is if I have this piece right here and I'm trying to figure out what that looks like, if the roots are imaginary, what that means that graph is going to look like is it will never hit the x-axis. So it'll either be something like that, or it could be something like this, or like this. Oops. Okay. So basically what I'm trying to get you to see is there are no zeros here. And if there are no zeros, this is not going to have, this section of my velocity is not going to have any critical points. So then what that means is if I'm doing a velocity sign chart, the only critical point that's going to be on there is 1. And then you're going to just take values and you're going to plug in to the velocity, which is right up here. Let me box that off and see whether you get positive or negative. So I get negative and then I get positive. All right, so it's asking, let me see, when is the particle moving to the left? So when is the particle moving to the left? Right, so it's moving to the left between 0 and 1 because the velocity of particle P is negative during this interval. All All right, so the second part is asking to find the times during which the two particles travel in the same direction. So if things travel in the same direction, wouldn't that mean that their velocities will have the same sign? Okay, let's think about that again. If you're traveling in the same direction, if you're going to the right, then both your velocities would be positive. And if you were going to the left, then both your velocities would be negative, right? So what I did right here is this is just from part A, and this was our sign chart. And they were saying between 0 and 8, so I just put those as my endpoints. Okay, so then what I need to do is I need to take this velocity equation right here, and I want to have a sign chart for that because it's not particle P anymore, it's particle Q. So I'm going to do that off to the side here. And basically, I already have the velocity, so I don't even need to take the derivative. I just need to figure out where that velocity is equal to 0. All right, so let's see what we get. So we've got t, and then we should have -5, -3. So then we end up with t equals 5 and t equals 3. So let me go over here. I'm going to do my sign chart. And I should have, what, 3 and 5 on here? Okay, so 3 and 5. And I know this is an upward pointing parabola, so I know that that's going to go plus, minus, plus. And let me label this. This is the velocity of particle Q, right? Okay, so we're trying to see, find all the times during which the particles travel the same direction. Now, it doesn't say which direction. So we want to look and compare. So let's look and see what we have here. Well, I know between 0 and 1, particle P is negative. But between 0 and 1 here, particle Q isn't. So scratch that idea. Let's look between 1 and 8. Well, between 1 and 8, P is positive. Well, between 1 and 8, Q isn't, but between 1 and 3 it is. So there would be your first interval. So we've got 1 and 3, they're both positive. All right, let's keep going. How about between, I'm going to start with Q since there's a lot more changes in Q's sign chart than P's. So let's say 3 to 5 is negative. Well, 3 to 5 here is not negative, so that's a no-go. Let's go from 5 to 8. Do you see that from 5 to 8, Q is positive? And look, from 5 to 8, P is also positive. So there would be our next interval. So we're going to say between 1 and 3, okay, or also from 5 to 8, because signs are the same for both velocities during these intervals.